Okay guys, we're going to add a couple of fractions together. So this is from A3, equivalent expressions or rational expressions. So we've got these this expression and it's got two fractions and we want to add them. So we need common denominators because this and this are not exactly the same. But before we do that, we should factor this guy just to see if there is anything like an x plus 5 in there that we don't know about. Okay, so let's factor it. It's a complex trinomial. So I'm not going to go super slow here. So if you don't know how to factor, you need to go to a factoring video and figure that out first, or this A3 topic is going to be really hard for you. Okay, so we're factoring this guy. So we're looking for two numbers that multiply to negative 10, because 2 times negative 5, and add to 9. So I'm just going to do it off to the side here. And we're going to replace the 9x with those two numbers that we find. So I'm thinking 10 and negative 1 would multiply to negative 10 and add to positive 9. So I'm going to replace that 9x with a 10x and a minus 1x, and then we'll keep the minus 5 there. Okay, next I'm going to split it in half and common factor each half. So I'm going to take out a 2x, leaving an x plus 5. And I'm going to bring down that minus sign. And x minus 5 doesn't really have anything in common, so I'm just going to factor out a negative 1, leaving x plus 5 in the brackets. Now that the brackets are identical, what we're actually doing, that I feel like half of you don't know, is we're actually common factoring the x plus 5s out. And what we have left from this first term is just the 2x. And what we have left from the second term is the minus 1. So that's how we factor a complex trinomial. So let's rewrite this. We have x plus 3 over x plus 5 plus x plus 2 over x plus 5 times 2x minus 1. So now that we've factored it, we can see they both have an x plus 5 in common, but the first fraction is missing that 2x minus 1. So to make them identical, we will just multiply the top and bottom of this fraction by 2x plus 1. Now they have a common denominator. So, rewriting this, we'll have x plus 3 times 2x plus 1 plus x plus 2 divided by x plus 5 2x plus 1. So once we got them in common denominator, which we did, then we can just add the numerators together. And that could be your final answer, or you maybe want to clean it up a little. I mean, I personally, this is kind of a weird form to leave it in. It's like kind of looks factored, but not because of this plus sign. So I'm just going to go ahead and expand things out. Whatever you do, don't get crazy with your canceling and think that you can actually cancel like this and out or something, because you can't. It has to be in factored form for you to do that. This plus is like, it would mean that you'd have to cancel out a 2x plus 1 from this term and from this term. Okay, so I'm going to expand that bracket, and I'm going to just do it in one step. So 2x times x is 2x squared. Then x times 1 is 1x. 3 times 2x is 6x. So that's 7x in the middle. And then 3 times 1 is 3. And then plus x plus 2 over x plus 5 times 2x plus 1. Okay, then I'll just collect my like terms on top. So I got 2x squared, 7x plus x, so that's 8x. 3 plus 2, 5. Over x plus 5 times 2x plus 1. And that would be it. This would be my final answer. And if I wanted to state my restrictions, if it asked me to, then I would just look at my denominator, and I would determine that x cannot equal negative 5, because if that was negative 5 plus 5, that would be 0. And this one I know that x cannot equal negative a half. And if you don't know how to do that, you just set that bracket equal to 0 and isolate x. divided by 2, so x equals negative a half. So that's how we get that. So that's your final answer, and these are your restrictions. So that would be how you add two rational expressions together, or subtraction works the exact same way. So you got to find a common denominator and then add or subtract the tops. And that's it.